Welcome to The Explainer. Every living thing, it's part of this huge invisible network, right? A web of life that's run by just a few basic rules. So today, we're going to dig into those rules. We'll look at everything from a predator catching its prey all the way up to the massive process that creates totally new species.
So let's just start with the biggest question of them all, the one that really gets to the heart of ecology. How does any of this actually work? I mean, think about it. How do millions of different species all manage to live together, to compete, and to rely on each other in this incredibly fragile balance that keeps everything going?
All right, so here's how we're going to break it down. We're going to start with the basics, the fuel of life itself, energy. Then we'll jump into that constant push and pull between different species. And finally, we'll zoom out and see how all these daily struggles actually shape evolution over the long haul.
Okay, section 1. Every story's got a beginning, right? Well, in the story of life, it all kicks off with energy. And where does pretty much all of that energy come from? Yep, the sun.
So one of the simplest ways we can track this energy flow is with something called a food chain. It's basically a straight line that shows who eats who. But more than that, it shows exactly how that initial energy from the sun gets handed off from one living thing to another.
And in this chain, you've got different roles, or what scientists call trophic levels. It all begins with the producers. Think plants that are masters at capturing sunlight. Then they get eaten by primary consumers, who in turn get eaten by secondary consumers. And you get the idea. It's a ladder. And see those arrows? They always point from the thing being eaten to the thing doing the eating. That's the direction the energy is flowing.
But let's be real. Nature is almost never that simple, is it? A fox doesn't only eat rabbits, and rabbits have to worry about a lot more than just foxes. The real world is, well, it's a lot messier.
And that's exactly why scientists use the idea of a food web. This is way more realistic. It shows how all those individual food chains are actually tangled up together in this big, complex network where everyone depends on everyone else. And what this really highlights is just how fragile the whole system is. I mean, if you were to take out just one of those species, let's say the grasshopper, it's not just the grasshopper that's gone. It sends ripples through the whole web. Suddenly, the spiders might not have enough food, and that means the birds that eat the spiders are in trouble. You see? Every single link in that web really matters.
Okay, now this is super important. The way energy gets transferred is actually incredibly inefficient. For every step you go up the food chain, roughly 90% of the energy is lost. It just dissipates as heat. And that's the reason why you almost never see food chains longer than 4 or 5 steps. It's also why top predators are so rare. By the time you get that high up, there's just not a lot of energy left to support them.
All right, let's zoom in on one of the most classic, most dramatic dynamics in that entire food web, the relationship between predators and their prey. This is like a constant dance, a back and forth for survival that literally shapes the populations of entire species. You can think of it like a biological arms race. Predators are always evolving better tools for hunting, getting faster, developing sharper teeth, honing their senses. And right alongside them, the prey are evolving their own set of tricks to survive. Better camouflage to blend in, bright warning colors to say, hey, I'm poisonous, or just pure, unadulterated speed. And what comes out of this arms race is this really fascinating cycle. When there's a ton of prey around, it's a buffet for the predators, right? So their population explodes. But more predators means, well, fewer prey. And when the food source dries up, the predator population crashes. The really cool thing to watch for is the delay. The predator numbers always follow the prey numbers, rising and falling just a little bit behind.
But it's not all just about hunter and hunted. That's not the only kind of conflict out there. Sometimes your biggest problem is the guy living right next door, especially when you both want the exact same thing, and there's not enough to go around.
And this competition plays out in two main ways. First, you've got intraspecific competition. That's between members of the same species. Think of two bucks locking horns over territory. Then there's interspecific competition, which is between different species, like when lions and hyenas square off over a fresh kill. But no matter who's involved, the root cause is always the same. There's just not enough to go around.
Okay, now let's talk about a much sneakier kind of conflict, parasitism. This is a totally one-sided deal. You've got one organism, the parasite, that benefits, but it's always at the expense of the other one, the host.
And these parasites come in two main flavors. You've got your endoparasites, which live inside the host's body. Tapeworm is a classic creepy example. And then you have ectoparasites, which live on the outside, like fleas or lice. But whichever way it goes, it's not a great situation for the host.
So we've looked at all these daily battles, right? The fight to eat, the competition for space, just surviving. But now let's pull the camera way, way back. What happens when you let these struggles play out for not just days or years, but millions of years? Well, they end up driving the biggest show of all, evolution.
Yeah, all of these pressures we've been talking about, from predators, from parasites, from your competitors, they can all push a species to a point where eventually something amazing happens. It's called speciation, and it's the process that literally creates brand new species. It's the engine behind all the mind-boggling diversity of life we see on our planet.
So how does this actually work? Well, a lot of the time it kicks off with some kind of isolation. Imagine a population of animals gets split in two by, say, a new river or a mountain range. Now you have two separate groups, and each group starts adapting to its own specific environment. You let thousands of generations pass, and they start to change in different ways. They become so different that eventually, even if that river dried up and they met again, they wouldn't be able to breed with each other anymore. Boom, just like that, you've gone from one species to two.
But here's the thing. Evolution isn't only about creating new things. It's also about losing them. Extinction has always been a natural part of the story of life, but the speed at which it's happening right now, there is absolutely nothing natural about it.
When we talk about extinction, we're talking about the end of the line. It's permanent. It means that an entire species is gone, forever, with not a single one left anywhere on Earth. That chapter in the Book of Life is closed for good. Now, sure, natural events can cause extinctions. That's always happened. But the science is crystal clear that today, human activity is the #1 cause. We're hitting the accelerator on extinction through things like destroying habitats, changing the climate, overhunting, the list goes on.
And that really brings us to the final and maybe most important question. We spent this time looking at these ancient, complicated rules that hold the web of life together. But here's the catch. As the dominant species on this planet, we're not just playing the game anymore. We are actively changing the rules themselves. So the question we all have to ask is, what's our role now? What's our responsibility in this new food web that we are creating?